question 2. An experiment involves asking 2 different people the day of the week on which they were born. The outcome is recorded in the form day 1, day 2. For example, if both of them were born on a Monday, this is written as Monday, Monday. And it says write out 3 possible outcomes of this experiment. Okay, so any pair of days. So you could put Tuesday, Saturday. You could have Friday, Monday. You could have Saturday, Saturday. Okay? Any pair of days. I wouldn't use the Monday, Monday because they've already given that to you as an example. So don't use that one again, use a different one. Okay? How many different possible outcomes are there? Well, person 1 can be born on one of 7 days of the week. Person 2 can be born on one of 7 days of the week. So, to get how many possibilities there are, simply multiply the 2 together. 7 by 7 gives you 49. Okay? If there was a third person, let's say, for example, it was 3 people, so you could have a Tuesday, a Saturday, a Sunday. Okay? Then person 3 would also have 7 options, and you multiply the 3 of them together. If they tell you that, say, person 2 could only be born on a weekday, then that would be 5 options for person 2, and you still multiply them together to get your answer. Okay? In this case, person 2 has 7. So that's your answer. Assuming that every day of the week is equally likely, answer the following. And it tells you you may use the opposite page for extra work if you need to. Now, what they're talking about using the opposite page for extra work is they're talking about this, doing a sample space. Okay? The way you work out a sample space is you work out a grid of what are the things that are likely. So on this, you have, this is person 1 up here, and this is person 2 here. So person 2 can be born on a Monday, person 1 can be born on a Monday, person 2 a Monday, person 1 a Tuesday, and so on. So you get all your possible pairs. You just fill this in, okay, and you just fill in all the 49 squares to get all your possible answers. So that this will be Sunday, take this one here. I'm not going to do them all in, but you get the general idea. Okay? If you do your sample space, if you take it, only take you 2 or 3 minutes, if you do your sample space, it will make answering the next 3 questions much more easy. So the first one is, find the probability that both people were born on a Wednesday. Well, you go to Wednesday on person 1, Wednesday on person 2, and see where they meet. And there's only 1 square where it's a double Wednesday. So the probability of the person born on a Wednesday, both born on Wednesday, is 1 out of 49. And remember in question 1, we said when it's equally likely, you simply write the answer you're looking for over the total outcomes. So the answer we're looking for is Wednesday, it's 1 over the total outcomes, which is 49. Okay? Find the probability that both people were born at the weekend. Okay, so Saturday or Sunday, but both of them. So this person's Saturday. This is a Saturday, Sunday. This is a Sunday. Okay, this doesn't work because that would be a Sunday, Friday. That would be a Sunday, Friday. This doesn't work because that would have a weekday involved. So the only days that have all weekend days are those 4 squares there. So your answer to number 2, the weekend, is 4 out of 49. Okay, because there's 4 possible squares and 49 is the total. Okay? Last question. Find the probability that at least one of them was born at the weekend. So here you want all of your weekend squares for both the people. So that's for this person, person 1. Tuesday, Sunday, Wednesday, Sunday, your Thursday, Sunday, and your Friday, Sunday. Okay, so person 1 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 for person 1. And person 2, now don't overlap. You've already done these 4 boxes, are included in person 1. So do the rest of the weekend for person 2. So this is Saturday, Friday. This is Sunday, Friday. This is Saturday, Thursday. Sunday, Thursday. Saturday, Wednesday. Sunday, Wednesday. Saturday, Tuesday. Sunday, Tuesday. Saturday, Monday. And Sunday, Monday. Okay? So you have the 14 there. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So your answer is at least 1 at the weekend is 24 out of 49. Okay? And that's question 2 done, lads. That's it.
14 and 14, 28.
Yeah, but you don't count these.
You
You don't have to count those twice, okay? If you count them twice, you're going to skew your answer. You get the wrong answer. So when you've already counted those 4 squares, don't count them a second time.
So you're just counting the rest going across and then the
Yeah,
rest up one?
just count each square once.
Yeah.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. How am I getting 22 this time? Oh, I left out 1. I left out this 2. 24. Okay? So 24 out of 49. So just make sure, be careful of that, and I'm glad you said it, Paul. Make sure you count every square only once. Alright? That's question 1 and question 2. Probability, very nice.